is Kenneth, and my project is Planet with Burst Forwarding. So just a quick overview of my presentation today, background technology of my project, problem statement, and my proposed solution, and the methods that I use in the project. So this is the typical wireless setup where in the network we need access point or infrastructure to be able the nodes in the network to communicate to each other. Without infrastructure, they won't be able to communicate. However, in ad hoc network, we don't need the infrastructure or access point because the nodes that are in the network act as a router and a client, so they can forward messages of the other nodes to the other clients. So bandnet is another type of ad hoc network, except that instead of using laptops or smartphones, their cars communicate to each other. And it's like having a computer built into their cars so they can be able to communicate. And here are the bandnet application where traffic information, business and entertainment, and safety. For traffic information, let's say you're driving and while you're driving and 2 miles ahead of you there's some traffic, then the cars in front of you will transmit message that there's some traffic going on that area, so you can have a reroute on your way. And business and entertainment is basically having internet in your car, so maybe while you're driving, the passengers behind you can check their Facebook. And safety basically transmit alert messages to the other drivers. So, problem statement. Sometimes accidents happen because of mechanical failures, but most of the time it happens because of the drivers are not paying attention or not focused on the road condition. The problem with that is that drivers have only a very short period of time to react to the condition ahead. And if they don't react quickly, accidents happens, and accident happens most of the time. And our proposed solution, or our goal of the project, is to deliver the message from car A to car B in a very short period of time, within, let's say, less than the average driver's reaction time. If we see it here, there's only 2.5 seconds to react to that, depending on the speed and whatever object or condition ahead of while you're driving. So this is part of what we're trying to solve. With the current technology, we use 802.11 for wireless because it makes sure that there's only one node to transmit at the same time, because in a wireless network, if every node starts to transmit, collision happens. As an analogy for real life, it is a private, polite conversation room. The reason why 802.11 is successful because of CSMA-CA. So if I'm the node, before I transmit, I'll do back off. Back off is a random time. For example, my backup is 5 seconds. I'll do 5, 4, 3, 2, 1. And then after that, I'll check the channel if it's free or not. If it's free, I can send a message but before I can send a message, I'll still have to do diffs. Diffs is a very short period, very short time. If backup is 5 seconds, diffs is 1 second. So I'll do my diffs 1, and then now I can transmit the message. RTS is request to send. If I have a message to Dr. Tao, I'll send a request message, and if he receives it, when he receives it, if it's clear to send, he will send a message to me that okay, it's clear to send, and then that's the only time I deliver the message. And acknowledgement is just the acknowledgement to make sure that he receives the message. And here's the analogy, real life analogy of the protocol. So here, A is having conversation with C. And because of the protocol, D and B will be silent until A finishes his talk. However, with the current protocol, if D sees there's a fire going on, he will let A finishes his talk first before he can shout fire. So in real life, this is not how we do. But in burst forwarding, we're trying to propose to what we're proposing is to change that protocol. So if there's an alert message, he will not have to wait to finish the other node to. He will not let the other node to finish the transmission. So instead, he will capture the channel first and burst forward. So this is kind of like a formal representation of how wireless networks work. So inner circles are the range of the nodes. So if A wants to send message to B, it will send a RTS. The protocol only allows one node to transmit at a time. And then the other node gives. And then, like what I said earlier, it will go RTS, CTS, and then transmit the message. And our proposed solution is burst forwarding, because burst forwarding immediately transmit the message, and if there's an alert message, the node doesn't have to do the back off. So it can capture the channel quickly. And here's the representation of the same slide, but without the back off. I'll go with it faster here. So if you see it here, C it into the back off here. So while the other node still doing the alert message to other nodes. So if this is a advantage with burst forwarding, if accidents happen there should be an alert message. This car should transmit alert messages to the other cars, so they're being aware to that situation. And my methodology that I use is simulation and programming. And from my preliminary implementation, I use 3 nodes. And here's the code that I think the back off is happening, but I'm not sure yet. I still have to talk with Satya and see this. So from my preliminary implementation, I have 3 nodes and 4 nodes. And here's the result.